Hello everyone, I hope you are safe and healthy. So this video is about the differential equations. I hope you have already gone through the blog. So we have discussed about what a differential equation is. Any equation having a derivative is called a differential equation. So let's say we have dy over dx plus 7x is equal to 4y. So this is a kind of a differential equation because there is a derivative of y with respect to x, which we see over here. Likewise, another examples can be d square y over dx square plus 7 times dy over dx plus 6x is equal to 1. This is again an example of differential equations. Then we talked about in the blog, we talked about the order. So the order is the highest order derivative which is present in the equation. So for let's say we talk about these two examples. So this is dy over dx means that is of the highest order in this particular equation is definitely 1, because if there is nothing there, it means it's 1. So the order of this particular a differential equation is 1, so I'm going to write that order is equal to 1. Likewise, the order of this particular differential equation is 2, because the highest order derivative is present over here as 2. Likewise, let's say we have another differential equation which is d cube y over dx cube plus, let's say, 7x is equal to 4y plus 1. So we can clearly see that the highest order, and in fact the only derivative available in this particular equation, is 3. So we're going to write that the order of this particular differential equation is 3, and so on. So order is the highest order derivative which is available in a particular equation. Then we talked about the broad classification of differential equation. The differential equation can broadly be classified as ODEs and PDEs. So when we talk about ODE, which is an ordinary differential equation, and then we talk about PDE, which is a partial differential equation. So ordinary differential equation is when all the derivatives are with respect to a single variable. So let's say we have a differential equation of the sort 7 d raised to the power 4y over dx raised to the power 4 plus 3 d cube d cube y over dx cube plus, let's say, we have 7 d square y over dx square plus 4 dy over dx plus y is equal to 7x. So in this case, just the order of this particular differential equation is 4 first off, and this is an ordinary differential equation because all the derivatives are with respect to x only. So that is the only variable with respect to which the derivative is available. On the other case, when we talk about partial differential equations, so the derivatives are actually with respect to with respect to more than one independent variable. So let's say we have a differential equation of the form, and by the way, the partial derivatives are denoted by a symbol like this. So in the ordinary differential equation, this is a d, while this is a symbol like this. So we talk about, let's say, dy over du plus dy over d, let's say, v is equal to 1. So this is a partial derivative equation. It can be of an order greater than 1 as well. So let's say we have d square y over the partial derivative with respect to u and with respect to z plus dy over the partial derivative of y with respect to, let's say, t is equal to 7u. So this is again a partial differential equation. So these are the two broad categories of the differential equations. Then we talked about the two categories of ordinary differential equations. So the first one was separable differential equations. So this is the most common, which looks of the form dy over dx is equal to g of x times, let's say, f of y. The idea behind this is we are able to separate the function of x and the function of g. So since the function of y will be integrated with respect to y, so we divide both sides by fy, so it comes over here, and we multiply both sides by dx, so it goes over there, and then these can be integrated easily to get the particular solution. We are going to do a couple of examples on the separable differential equation, and let's see how to solve them. So let's talk about the first one. And by the way, all the differential equations which are separable may not look in this format. So we'll see in the examples that sometimes we have to rearrange those to make them appear in this format, and then we can integrate them. So the first one is dy over dx is equal to negative of 6xy. We are interested in clubbing up all the y's together with dy and all the x's together with dx. So dividing both sides by y, we have the y over here, and over here we'll have negative 6x only, and we already have dx, so let's put in dx as well. So it's y and dx. Multiplying both sides by dx, so it will become dy over y is negative 6x dx. Now, since all the x's and y's are separated, and that's what the separable means, and all the x's are with dx and all the y's are with dy, so we are going to integrate both sides. So if you are going to integrate dy over y, the integration will be natural log of y, and we put an absolute value symbol. The 6 is a constant. In fact, negative 6 is a constant, so that comes outside. And integral of x is x square over 2 plus the constant of integral is c. So that's going to look like ln absolute value of y is equal to negative 3x square plus the constant of integral being c, which is the final answer. Let's talk about another one. This one says that we have dy over dx is equal to 4 minus 2x over 3y square minus 5. Again, we are gonna pull up all the y's together and all the x's together, and fortunately there is only one expression with y which is in denominator, while only one expression of x which is in the numerator. So what we are going to do is we are going to put this expression of y with dy and with this expression of x with dx, and let's see where we get. So multiplying both sides by 3y square, in fact, not multiplying both sides, since this is a proportion. So what we are going to do is we are going to cross multiply these two. So if we do that, we have dy, in fact, that can be written as 3y square minus 5 dy, and that's going to be equal to 4 minus 2x dx. And since everything is separated, we are going to integrate both the sides. So that's going to look like 3y squared dy minus 5 dy. I've just opened up the parentheses, and likewise this is 4 dx minus 2x dx, and I'm going to integrate all the sides. So integral of y square is y cubed over 3. Integral of dy is just y. Integral of dx is just x, and the constants just remain outside. And integral of x is x square over 2, and then we have a constant of integral as well. So this 3 and 3 gets cancelled, this 2 and 2 gets cancelled, and what are we left with is y cubed minus 5y is equal to 4x minus x square plus the constant of integral c, which is the final solution of this particular equation. Let's talk about another one. So we have, in this case, dy over dx is equal to 6x y minus 1 raised to the power 2 over 3. Again, the drill remains the same. So we are going to divide both sides by 5 minus 1 raised to the power 2 over 3. And we are going to take the dx over to the other side. And since they are separated, we are going to integrate both. This can also be written as y minus 1 can be taken in numerator, so the power becomes negative, and this is how it is, and this is 6x dx, which remains as it is. Integral of y minus 1 raised to the power minus 2 over 3 is we add 1 to the power, so it becomes 1 over 3, and we divide this by the power. and this becomes x square over 2. So it's very much important that we remember all the rules of the differentiation, of the integration. Otherwise, solving the differential equation would be really challenging. So this 3 comes on top. So we have y minus 1 raised to the power 1 over 3 is equal to 2 times 3 is 6. So this is 3x square plus c, which is the final solution of the differential equation. Let's talk about another one. So this one is y dy over dx is equal to y square plus 1 tan x. So we have a trigonometry function over here. Again, the drill remains the same. So clubbing all the y's together, so dividing both sides by y. So we have y square plus 1 over y, and tan x remains as it is. So clubbing all the terms now of y's with dy and of x's with dx. So what I'm going to do is I'm going to multiply both sides by dx. So let's see how it looks like. So it's going to be y square plus 1 over y tan x dx. Now definitely I'm gonna I do want this thing over to the other side, right, with dy. So what I'm gonna do is I'm gonna multiply both sides by y over y square plus 1. So if I do that, this particular term will just become 1. So this will be equal to 10x dx, and now we can integrate it. Uh, the left side is not so much easy to integrate, so we might end up with a t substitution. So let's do that. What we are going to do is we are going to substitute y square plus 1 as t. So this will look like 2y dy is equal to dt. So if we make the substitution, the further solution looks like the y dy can be replaced by dt over 2, and the y square plus 1 is t anyway. So this is how the left side looks like. The right side is 10x dx, so we don't have to make anything special for it, because that can be integrated. Now the integration of dt over t becomes natural log of t, and integration of 10x is a natural log of sec x. So we are going to write sec x over here, and plus the constant of integral c. But mind that we cannot leave the solution like this, because t is a variable which we introduced. So we are again going to replace t by y square plus 1, and the rest of the terms remain as it is. So this will be the final solution. Let's take another one. So we have y dash is equal to e raised to the power negative y over x cube plus x. So I talked about in my blog that whenever we have y dash, it means that it's a derivative of y with respect to x. That is a customary notation. So what we are going to do is we are going to club. If we are not comfortable with working with y dash, we can always replace it with dy over dx. So it's going to look like this. Clubbing all the y's together, we're going to divide both sides by y. So it's going to look like e raised to the power negative y over y, and x cube plus x remains as it is. And finally, we are going to, I think, club all the terms with y's with dy. So it's going to look like dy times actually it's going to look like y over e raised to the power negative y times dy. So what I have done is multiplied both sides by y and divided both sides by e raised to the power negative y, and taking dx over to the other side, multiplying both sides by dx. So it's going to look like this. uh, now moving further to it, this can be written as y times e raised to the power y dy, and this is going to look like dx over x can be taken out in this case, so we are left with x square plus 1. All right, so this is not so much easy to integrate, because on the left side we have to use the integration by parts, and over to the right side we have to do I think the partial fraction. So over to the left side, if we are going to take this one as the first term and this one as the second term. So this is going to look like the first term remains as, so we are going to do it separately, right, in two parts. So the first part is when we are integrating y e raised to the power y dy. So that's going to look like first term is as it is, integral of second term minus integration of differentiation of y is 1, integral of y is e raised to the power y, and dy remains as it is. So it is y e raised to the power y minus e raised to the power y. Uh, Now we're going to do the partial fractions. So let me add another page and do the partial fraction over here. So 1 over x times x squared plus 1, we are going to write it as a over x plus bx plus c over x squared plus 1. So it's going to look like 1 is equal to a times x squared plus 1 plus bx plus c times x. So I've just simplified both the expressions. So it's going to look like a is equal to 1 is equal to ax squared plus a plus bx squared plus cx. So I'm going to compare both the terms now. So or in fact, I'm going to first simplify it as x squared is taken as common. So that's a plus b plus cx plus a. So clearly, if I place a as 0, x as 0, because I'm going to find the constants a, b, and c now. So it means that 1 is equal to a. If I'm going to substitute x as 1, so it will look like 1 is equal to a plus b plus c plus a again, which is anyway 1. So it's going to look like 1 is equal to 1 plus 1 is 2. So it's 2 plus b plus c, which is going to look like b plus c is equal to minus 1. So let's box it in. And the other substitution will be, let's say, x as minus 1. So 1 is equal to a plus b minus c plus a, which means that 1 is equal to 2 plus b minus c, which means that b minus c is equal to minus 1. So from the equation first and second, if you are going to add both, I'm going to get 2b as negative 2, because c and minus c is cancelled, which means that b is negative 1. And if b is negative 1, which means that c is equal to 0. So the partial fraction is going to look like a over x, which means that it's 1 over x. It's 1 over x plus bx plus c. So the b is negative 1. Negative 1 x plus 0 over x squared plus 1. So that's how the partial fraction is going to look like. And this is nothing but equal to 1 over x squared plus 1. So if we are going to integrate this, we are going to integrate, we are going to have a dx over here, and we are going to have dx over here as well. So dx over x integral is ln absolute value of x, and this is going to look like negative x dx over x squared plus 1. Negative sign can come outside, and with a t substitution, this integral is 1 over 2 ln x absolute value of x squared plus 1. So this is how this integral would be. So what we are going to do is we are going to substitute the same thing over here to get the final answer. So it's going to be y e raised to the power y minus e raised to the power y, and this integral is nothing but ln absolute value of x, ln absolute value of x, that was minus 1 over 2 uh, ln absolute value of x squared plus 1 plus the constant of integral is c, which is the final answer. Let's talk about another one. So we have, I think this is number 6. So let's talk about, this is the last one, last example which we are taking in the separable. So it's x squared y dash is equal to 1 minus x squared plus y squared minus x squared y squared. So taking a glance at this particular question, it doesn't really look like separable. So we have to make some efforts to first simplify it, and let's see if we can convert that into separable. So let's take y square as a common factor from here. So we are left with 1 minus x square. And if we look carefully, we have 1 minus x square as a common factor once again. So we are left with 1 minus y square over here. So y dash is dy over dx. We know that. So let's write it that way. This is 1 minus x square. This is 1 plus y square. So what we are going to do is divide both sides by I think 1 minus x square. So 1 minus x square comes over here, and multiply both sides by dx. Uh, in fact, that may not be a great idea because dy is on top. So what we are going to do is dividing both sides by x square. So it's going to look like 1 minus x square over x square, and 1 plus y square remains as it is. Now dividing both sides by 1 plus y square. So it's going to look like this. So we have 1 minus x square over x square as it is, and dx comes over here. Since everything is now separated, we are gonna integrate this. So let's integrate it over here. So integration of dy over y square plus 1 remains as it is, and this can be written as, if we separate the denominators, it can look like this. And now this can be easily integrated. This integration is nothing but uh, this is tan inverse x, or arc of 10x. This is nothing but x raised to the power minus 2 dx integral, and this is minus of dx integral. So that's going to look like tan inverse x is equal to x raised to the power minus 1 over minus 1 minus x plus c. So that's going to look like tan inverse x is equal to negative 1 over x, negative 1 over x minus x plus c, which is the final answer. The next type which we discussed was about the linear type of differential equation, which looks of the form dy over dx plus px into y is equal to qx. So a way to remember that this is a linear differential equation is, you should have dy over dx over here, and the next one should be of the type px times y. So there should be a separate y followed by a function of x, and the right side should not have anything with respect to x, with respect to y, I pardon. It should have only with respect to x. If at all there is any function, it should only be with respect to x. Let's try out a few examples. So another thing was the solution for this type, as I talked in the blog, that we find the integrating factor, which is nothing but e raised to the power px dx, and the final solution is y times the integrating factor is equal to qx times integrating factor times dx. So we integrate this particular thing as complete. So let's talk about an example. So we have dy over dx plus 2y over x is equal to 4x. So let's try to integrate this. Uh, we have to first identify what is px. So px is the coefficient of y over here, which is 2 over x. So since px is 2 over x, we can easily find the integrating factor as e raised to the power 2 over x dx. So if you're going to integrate this, that's going to be ln x. So ln x is going to be e raised to the power ln x squared, using the properties of the logs. We can write it like this, and this is going to simplify as e raised to the power 2 ln x, and ln x. In fact, um, this is going to simplify as just x square, because we have a property that these two can be swapped, and when swapped, ln e is just 1. So this is just x square. So this is the integrating factor. So the solution is going to look like y times integrating factor is equal to, the right side is 4x, so it's going to be 4x integrating factor dx. So I'm going to replace integrating factor by x square. So this is yx square is equal to 4x x square dx. So that's going to look like yx square is equal to the integration of x cube is x raised to the power 4 over 4 plus c. So the solution is yx square is equal to this 4 and 4 is cancelled. So that will be x raised to the power 4 plus c, which is the final answer. Let's talk about the next example. So we have dy over dx minus y over x is equal to x cos x. Again, we are going to locate px first. So px is -1 over x. So the integrating factor is going to be e raised to the power -1 over x dx. The integration of 1 over x is natural log of x. And if we take negative over to the power, this is going to look like an ln 1 over x. So when simplified, integrating factor is just 1 over x. So after doing that, the solution becomes y times integrating factor is equal to the right side, which is x cos x, times integrating factor, which is 1 over x, times dx, and we integrate the right hand side. So it's y over x because if is y over x. This is going to be x and x is cancelled, and the integral of cos is just sine x, plus the constant of integral is c. So I think this would be the final answer. Let's talk about another one over here. So we have this one as x square plus 1 y dash plus 3xy is equal to 6x. So first off, this does not look like the linear differential equation because if you recall, the linear has dy by dx as a standalone element, but here we don't have dy by dx as a standalone element. But we can make it. We can divide the complete equation by x square plus 1. So it's going to look like 3x over y dash plus 3x over x square plus 1y is equal to 6x over x square plus 1. So now it is converted into a linear equation. So we're going to find its integrating factor, which is e raised to the power 3x over x square plus 1 dx. So this is how it's going to look like. So again, we have to make a t substitution, and if we do that, the integral comes out as 1 over 2, a natural log of x square plus 1. So this can also be written as e raised to the power natural log of x square plus 1 raised to the power 3 over 2. And finally, this comes down using the property. So this is the final integrating factor. So if you are gonna simplify this further, the integral will look like y times integrating factor, which is x square plus 1 raised to the power -3 over 2, is equal to the right side, which is 6x over x square plus 1 times x square plus 1 raised to the power -3 over 2 dx, and we are going to integrate this. So this is going to look like y over x square plus 1 raised to the power -3 over 2. 6 comes outside, and this when simplified becomes x square plus 1 whole square. So we are going to make a t substitution over here if you want to integrate. So x square plus 1 is going to be t. It means that 2x dx is going to be dt. So the right side is going to look like dt over 2t square. So that's how we're going to integrate. And the left side is going to remain as it is. So y over x square plus 1 raised to the power -3 over 2. So this is again going to look like y over x square plus 1 raised to the power -3 over 2. 2 times 3 is 6, so that's going to be 3t raised to the power -2 dt. So the integrals look like -3 over t plus a constant of integral is c, y over x square plus 1 raised to the power -3 over 2, and t is nothing but x square plus 1. So it's -3 over this is going to be -3 over x square plus 1, and over here we have plus c, and over here we have y over x square plus 1 raised to the power -3 over 2. So this is gonna now look like y times the integrating factor, which is x square plus 1 raised to the power 3 over 2, is equal to the right side, which is 6x over x square plus 1 times x square plus 1 raised to the power 3 over 2 dx. So we are going to integrate this. So this is going to look like y times x square plus 1 raised to the power 3 over 2. This is when simplified becomes 6x times x square plus 1 dx. So this can be written as 6x cubed plus 6x and dx. should be integrated. 6 can be in fact taken outside, so this is going to be x raised to the power 4 over 4, and this is going to be x square over 2, and then we have a plus c, the constant of integral. So this is going to look like we have 6 when is taken inside, so this is 3 over 2. In fact, we can take a common denominator as 4, so it's going to look like 6 over 4, x raised to the power 4 plus 2x squared, plus the constant of integral is c. So now it's going to look like we have y times the integrating factor, which is x squared plus 1 raised to the power 3 over 2, is equal to the right side, which is 6x over x squared plus 1 times x squared plus 1 raised to the power 3 over 2 dx. So this is going to look like y times x squared plus 1 raised to the power 3 over 2 will be equal to 6 root of x squared plus 1 dx, and there is an x over here as well. So we're going to make a t substitution, so the integration is going to be easy. So x squared plus 1 is t, which means that 2x dx is going to be dt. So the integration is now going to look like y times x squared plus 1 raised to the power 3 over 2 is equal to, this is going to be, I think, 3 root t dt. So if you're going to integrate 3 root t, that's going to be 3t raised to the power 3 over 2 times 2 over 3 plus c. So the c and c is 3 and 3 is cancelled, and this thing remains as it is. So finally, we cannot leave the answer in terms of t because that's a substituted variable. So the final answer looks like 2 times x squared plus 1 raised to the power 3 over 2 plus c. So this is the final solution. Let's talk about one last example in the linear differential equations case, which is y dash minus y is equal to 11 over 8 e raised to the power negative x over 3. So fortunately, in this case, the px is just 1 because the px is just negative 1 because the coefficient of y is negative 1. So the integrating factor is going to be e raised to the power negative dx, which is just e raised to the power negative x. So the solution is going to look like y times e raised to the power negative x is equal to 11 over 8 e raised to the power negative x over 3 times e raised to the power negative x dx. So this is going to look like 11 over 8 e raised to the power, since the powers will add, so it's going to be negative 4x over 3 dx. That's how it's going to look like, and y times e raised to the power negative x remains as it is. So it's going to look like y times e raised to the power negative x will be equal to 11 over 8 e raised to the power negative 4x over 3, and we have to make a t substitution actually over here. So when we do that, we'll have a negative 3 over 4 outside. So and then we have a plus c constant of integral as it is. So this is when written finally, the final equation looks like y times e raised to the power negative x is equal to negative 33 over 32 times e raised to the power negative 4x over 3 plus c. So this is the final answer. So this is all in this video. I hope this was helpful and you get some clarity about how to solve the equations. If you have anything from your side, anything which you are struggling in differential equations, please post it down in the comment section.